Welcome to Algorithm Sense channel. In this video, we will talk about the largest rectangle area in a circle whose radius is r, the largest confined rectangle area below the circle arc. Finally, we will calculate the total sum of the shown rectangles' areas. Stay tuned. If we have a circle as shown, the largest rectangle area can be drawn inside the circle is obtained by deriving a general relation for the rectangular area surrounded by the circle, then optimizing that area to get the maximum area. Let's call S stands for the rectangle area, theta stands for the angle between diagonals AB and CD. The rectangle area is the half of the diagonals multiplication multiplied by sine the angle between the diagonals. Rectangle area S equals half multiplied by 2r squared multiplied by sine theta. By varying theta, the rectangle area changes, so we will get the derivative as for theta ds by d theta equals 2r squared multiplied by cosine theta. By equating the derivative to 0, the angle that gives the maximum area is 90 degrees, which means the maximum rectangle can be drawn inside a circle is a square and the largest area is 2 multiplied by r squared. What about the largest rectangle area confined between the circle arc and the square? Following the same procedure, the general relation for the rectangle area can be calculated by multiplying EF by FG. EF equals twice HF and FG equals HK, which equals OK subtracted from OH. These lengths can be rewritten in terms of central angle theta. Note that theta is a variable, not a fixed value. HF equals twice r multiplied by sine theta, whereas OH equals r multiplied by cosine theta and OK equals r multiplied by sine 45 degrees, it is written also theta sub node. The derivative leads to a second order ordinary equation but in terms by squared cosine and squared sine. To solve this equation it should be written in terms of either cosine theta only or sine theta only. From the well-known Pythagorean identity, squared sine function can be written in terms of squared cosine, so the derivative can be rewritten as shown. This equation can be solved for cosine theta using the quadratic formula. Squared cosine coefficient equals 2, cosine coefficient equals -1 divided by square root of 2, and the free term c equals -1. From the geometry you should note that theta lies between -45 degrees to +45 degrees range, so the negative sign before the root is rejected since it leads to out of range values. The positive theta range is for the right sector while the negative theta range is for the left sector. Solving cosine theta equation for theta, it gives theta equals plus or minus 25.0896 degrees since cosine function is even function. A graph between S versus theta is drawn to ensure that theta value corresponds maximum area. That area is multiplied by 4 to get the whole area of the 4 rectangles. What about the maximum area above the yellow rectangle? Above the red one, and so on. Sure, we mean the rectangles which are still surrounded by the circle arc. Following the same procedure, we can evaluate the maximum area above the yellow rectangle. It is noted that the cosine relation contains the theta value which has been deduced from the previous optimization. That indicates the problem of evaluating the next maximum area can be iterated using the same relation. Substituting theta sub 1 equals 25.0896 degrees, gives theta sub 2 equals 14.3310 degrees, so the maximum area equals 0.0313 multiplied by squared r. Multiplying this area by 4 we can get the area of the 4 shown rectangles. From the previous two cases the maximum value of the successive areas can be obtained by iterating the previous relations. In the limit sense, the maximum area goes to 0 when theta goes to 0, that's also clear from the iterative equation for cosine theta sub I plus 1. The sum of the whole rectangle's areas is approximately 0.83 multiplied by squared r. An approximate value for the circle area can be evaluated using the whole rectangle areas in addition to the square area. Note this method cannot be given exact value for pi since there are left area. Thank you for watching. Please support us by sharing this video, subscribe and give us your feedback, like or dislike. Thank you.